Okay, I'll admit it. When I first saw this article, I thought, cement. Really? Not exactly the most thrilling topic, is it?
Uh-huh. I can see how you might think that.
But then I started reading, and wow,
Yeah.
this stuff is actually revolutionary. We're talking about making cement, that stuff that's in every building and road, without using fire.
Yeah. Pretty crazy, huh?
And, you know, we're not just going to skim the surface here.
Oh, wow.
This deep dive is all about going deep into the science behind it.
That's right.
We're going to unpack why this is such a big deal, like what it could mean for, well, everyone, actually.
Exactly. And we're basing this all on some really interesting research from Helmholtz Zentrum, Dresden, Rossendorf.
So buckle up, folks, because we are about to get our hands dirty with some seriously cool science.
Let's do it.
All right, first things first, cement. As unglamorous as it may seem, it's kind of a big deal, right?
Oh, absolutely. I mean, it's literally the foundation of our modern world. Think about it. Buildings, roads, bridges.
Everywhere.
Yeah, we rely on cement for pretty much everything.
But here's the thing. Making it, well, it's not exactly eco-friendly.
Yeah, that's the problem.
In fact, I was blown away when I saw the numbers. Cement production is responsible for, like, 8% of global CO2 emissions.
Yeah, it's a lot, up to 8%, to be precise.
That's almost 3 times what the entire aviation industry produces. Crazy, right?
It's a massive contributor to climate change.
Seriously. I mean, I see sidewalks and buildings every day, but I never really stopped to think about the environmental impact of making all that concrete.
Yeah, it's not something that most people think about.
So break it down for us. Why is traditional cement production so bad for the environment?
So about 2/3 of the emissions come from this chemical process called decarbonization.
Decarbonization, huh?
It's basically unavoidable. It's part of what happens when you turn limestone into clinker.
Clinker.
Yeah, that's like the key ingredient in cement.
Okay, so 2/3 of the emissions are kind of locked in because of the chemistry itself. But what about that other third?
Well, that's where the energy comes in. Traditionally, we're talking about heating stuff up to super high temperatures using fossil fuels.
Right, to get the reactions
Oh,
going.
exactly.
So burning fossil fuels equals emissions.
Pretty much. But that's where things get exciting. There's this project called ECem.
ECem.
Yeah, and they're all about electrifying cement production.
Hold on, electrifying it. How do you even electrify making cement?
Well, it's a pretty big collaboration. Scientists, industry leaders, they're all working together.
Okay.
And one of the biggest things they're trying to figure out is how to heat up limestone using electricity.
I mean, you can't just plug a rock into an outlet, right?
Right.
So how are they doing it?
Well, it's tricky. Limestone isn't very conductive.
Meaning it doesn't like electricity.
Basically, yeah. It doesn't let electricity flow through it easily.
Makes sense.
So they're exploring a few different approaches. One of them is this thing called inductive heating.
Inductive heating. Sounds kind of sci-fi.
It's pretty cool. Imagine a stovetop, but instead of a heating element, you have magnets.
Magnets.
Yeah, they create a magnetic field, and that heats up the pot.
So instead of a pot, it's like a giant pile of limestone.
Pretty much. But the challenge is, how do you heat up all that limestone evenly?
Good point.
That's where these tiny metal balls come in.
Wait, metal balls?
Yeah, they're called susceptors.
Susceptors. Okay, I'm intrigued.
Basically, they act like little heat distributors.
So they get hot from the magnet.
Exactly. And that heat spreads throughout the limestone.
That's pretty ingenious.
And get this, these metal balls, they can also grind the limestone at the same time.
Wait, hold on. They can grind and heat, like, simultaneously?
Yeah, it's wild.
Talk about efficient. But how does that even work?
It gets pretty complex. It all comes down to understanding how heat and gases flow within these massive cement kilns.
Oh, okay.
That's actually why they have fluid dynamics experts involved in this project.
Fluid dynamics, like the study of how liquids move.
And gases, yeah.
But what does that have to do with cement?
It's all about controlling the process. We're talking about huge amounts of material, super high temperatures. They need to make sure the heat is distributed evenly, that everything's flowing properly.
Otherwise, it's like a recipe gone wrong.
Exactly.
So how do they keep track of all that heat and gas flow?
They use this amazing technology called magnetic field tomography.
Magnetic field tomography.
It basically lets them see inside the kiln.
Like X-ray vision for heat.
Pretty much. It's incredible.
It's amazing how many different scientific fields are coming together to make this happen.
It really is. There's also this related EU project called Citadel that's focused on monitoring and controlling complex industrial processes.
Wow, it sounds like they're really going all out. But
Right.
how realistic is all this? I mean, we're talking about changing how cement is made globally.
Yeah, it's a massive undertaking.
Right.
Right now, they're still in the lab scale phase, testing things out.
Okay.
But they do have plans to build a pilot plant by 2028.
A pilot plant. That's a big step.
It is. And they're even considering combining different heating methods at that pilot plant, and like this inductive heating, and maybe even something called infrared radiant heating.
Infrared.
Yeah.
So like a giant heat lamp for rocks.
It's a bit more complicated, but you're on the right track.
But wait, why explore two different methods? If infrared's simpler, why not just stick with that?
Well, each method has its pros and cons. Inductive heating might be better for certain types of limestone,
Okay, makes sense.
and maybe infrared's better for others.
Mhm.
They're still figuring all that out.
So the pilot plant's going to be like a testing ground for all these different approaches.
Exact.
But before they even start building that, they want to be sure this tech's actually going to work on a larger scale, right?
Absolutely. You don't want to invest all that time and money if it's not going to pan out.
Right, of course.
So how do they test it before building a whole pilot plant? Well, they're using computer simulations and something called digital twins.
Digital twins, what are those?
Basically, it's like creating a virtual model of the whole process.
So they build a virtual cement plant in a computer.
Exactly. It's super cool.
But how can they be sure that what happens in that virtual world will translate to the real world? I mean, there are a lot of real-world factors that are hard to predict in a computer, right?
That's a great question. And it's something we'll dive into right after this.
Yeah, it's a fair point. There's always some risk when you're trying to take something from, a small lab experiment to a full-scale industrial process.
Right.
But these computer simulations, they're not just basic models.
No.
No, they get super detailed. I mean, they factor in all sorts of things.
Like what?
Like the size and shape of the kiln, for instance.
Okay, that makes sense.
The exact type of limestone they're using.
Uh-huh.
The temperature, the pressure inside.
Yeah, it's got to be hot in there.
Oh, yeah, incredibly hot. And even how the gases flow through the whole system.
So they're not just animating it. It's like they're actually trying to recreate the real-world physics in the computer. Exactly. And that lets the researchers spot problems early on.
Before they build anything.
Yeah, like way before. They might find that, I don't know, a certain design leads to uneven heating.
Oh, I see.
Or that the gases aren't flowing efficiently.
So they can tweak it in the virtual world.
Exactly. And hopefully avoid making costly mistakes later on.
That's really smart. So it's like a test run before the actual test run.
Yeah, I like that. A test run before the real deal.
But even with all this fancy tech, it still seems like a risky thing. I mean, what are some of the roadblocks they might hit when they actually try to build this pilot plant?
Well, you have to remember just how big industrial cement production is.
Yeah, it's massive, right?
It's huge. These kilns are processing tons and tons of material every hour.
Right.
So scaling that up from a small lab experiment, it's a massive challenge.
Yeah, I bet.
There are bound to be things they didn't anticipate.
Right.
I mean, it's one thing to get it working with a small batch of limestone in a lab, but to do it consistently at that scale in a real cement plant, it's a whole different ballgame.
Totally. And I imagine there are logistical challenges too, right?
Oh, for sure. Like,
Yeah.
where are they going to get all the raw materials?
Yeah.
How are they going to transport the finished cement?
Right.
And how do you integrate this new tech into the systems they already have?
Good points.
And then there's the cost, of course.
Yeah, money always comes into play.
Electric heating might be better for the environment, but it also has to make financial sense.
Right. If it's way more expensive, no one's going to do it.
Exactly. So there are definitely financial hurdles to overcome.
So is there any upside for the cement makers? Like, are there any financial benefits to doing this
Yeah.
beyond just, being good for the planet?
Well, actually, there might be.
Really?
Yeah, remember those regulations on carbon emissions?
The ones that are getting stricter?
Exactly. Well, companies that make low-carbon cement, they might actually have a competitive advantage.
Oh, I see.
They might be able to charge more for their product.
A green premium.
Exactly. Or maybe even attract some government subsidies or tax breaks.
So it's not just about doing the right thing. It could actually be good for business, too.
Exactly. It's like sustainability and economic growth. They can go hand in hand.
I like that. And it's not just about the companies either, right? This could create new jobs.
Oh, absolutely. A whole new sector focused on sustainable technology.
Manufacturing jobs, engineering jobs.
Research and development.
Yeah, the whole thing. It's
Yeah.
like this ripple effect, boosting the economy, helping the environment.
Exactly.
Okay, so we've talked about the technical challenges, the potential benefits, the impact it could have on the economy. But I think the big question everyone's wondering is, what does this all mean for everyday people?
That's a great question, and it's one we should definitely explore. Yeah, it's easy to get lost in the technical details.
Right.
But at the end of the day, this is about people.
It is, yeah.
It's about improving the quality of life for everyone.
Okay, I like that.
Think about it. Cement, it's everywhere, right?
Yeah, it's kind of the backbone of our world.
Exactly. Buildings, roads, bridges, sidewalks.
You name it.
It's all made possible by cement.
Okay, yeah, I get that. But honestly, most of the time, I don't really think about where it comes from.
And that's perfectly fine.
It just kind of is what it is,
Yeah, most people don't think about these things until there's a problem.
Right.
But the truth is, the way we make cement now, it has a huge impact on the environment.
Yeah, we talked about those emissions earlier.
Exactly. It's contributing to climate change, air pollution.
So if we could make it in a cleaner way,
It could have a real impact on people's lives.
like, could it actually make the air cleaner?
Absolutely. Reducing those carbon emissions, it helps fight climate change.
Right.
And that means cleaner air for everyone, healthier ecosystems,
Yeah.
a more stable climate for, future generations.
It's like, it's easy to think of climate change as this big abstract thing,
Yeah,
but this makes it feel a lot more, well, real.
it is real. And it's happening now. But the good news is we have solutions.
Like this ECem project.
Exactly. And it's not just about saving the planet. It's about creating jobs, boosting the economy.
Yeah, we talked about that.
It's a win-win, really.
I like that.
Yeah.
We can protect the environment and create opportunities at the same time.
Exactly. It's all connected.
It's funny, we started with cement,
Right.
not exactly the most exciting thing,
Yeah.
but it's led to this whole conversation about climate change, the economy, our health.
Yeah,
It really shows how everything is connected.
it does. And it all starts with innovation. Scientists pushing the boundaries, coming up with new ideas.
It's kind of inspiring, actually. It gives me hope for the future, knowing that there are people out there working on this stuff.
Me too. And it's not just about these big breakthroughs, It's about all of us making small changes in our lives.
Supporting sustainable technologies, spreading awareness.
Exactly. Every little bit helps.
Well said. So, to everyone listening, let's all do our part. And hey, maybe someday soon, we'll be talking about sustainable cement at dinner parties, and people will actually be interested.
I think that day is coming.
I hope so.
Yeah.
Well, this deep dive into the world of sustainable cement has been fascinating. Thanks for joining us, everyone. And until next time, keep learning, keep exploring, and let's keep building a better future together.